Okay, let's get going. I think Mehul said he might not be able to join today or will not be joining. Anyone want to share? Steve, were you able to get much done?
I've done a bit, but I haven't got any outstanding results yet. I can show you. I can show you where I'm up to, but I'm not winning the competition yet. Yes, like basically, I was just continuing on like with the idea of sort of trying to run segmentation and then run classification.
Yeah.
Can you see my screen here?
Yes.
Yeah. So there's a notebook I'd run. Can I move that? There's a notebook I'd run before, which was like the efficient net 3D and which one was it? Efficient net 3D. Yeah, so like it uses this efficient net 3D thing. It's the one, it gets about a 0.64 or something. So he makes 4 different models, and then yeah, like
and fumbles them, right?
And joins them together. Yeah. So what I found was, I don't know, can't get back to my thing. Yeah, so like what I found was somebody else had, it's a segmentation thing. Oh, yeah, so I can jump back to it now. And yeah, like what this notebook does, so like it segments, so you can see here it's like segmented the tumor in the brain here. So then I've like taken it and like just looked at this area, but I haven't got that far yet. What the segmentation thing does, it gives two bits of information back really. So yeah, it runs the segmentation and then it returns back the slice that has the maximum amount of tumor pixels on it, and then for each of the slices in the DICOM image, it'll return you back how many pixels on that slice had tumor and like the pixels themselves where the tumor is. So in the guy's 3D efficient net notebook, what he does, he just like takes the central slice of the image, and then I think he chooses like 32 either side of that, so like 64 in total to make his 3D channels. So what I was trying to do was, instead of just taking the central slice, I was going to take the slice which the segmentation model told me had the most pixels on it and use that instead. So like try and center in on the images or the slices that have the tumor. So yeah, so like you can see here, for like for these, like these 3 different studies or whatever, it comes back and like that works pretty well in terms of like the segmentation model finding the thing. But then I found when I just like basically I'm just taking the raw DICOM image and putting it in. So you can see here like this is the index of the slice, which has the maximum number of tumor pixels. And then this is like the first slice where it detected some tumor. And this is like the last slice where it detected tumor. So you can see for some of them, you get like quite a large range. So like here, yeah, so like on slide number 73, it started finding tumor and that went all the way to 161. Whereas like on other ones, there's like a very small gap between the two. So you can see here, it first found one on 14 and stopped finding on 19. So I think the problem was the fact that, you know, like some of the images, they're not in the same orientation. And the segmentation model, it's only been trained on axial T1W images. So like I think, yeah, so I'm just like sticking in the T1W image, but I think if it's not in the axial orientation, then the segmentation model gets confused and it doesn't work very well. And then the second problem is because of the fact that the 4 different MRI types, they're not sort of standardized. So again, it'll come back and it'll tell me the maximum index of the T1W image where the tumor is, but that doesn't like correspond to the same slice in the other 3 MRI types. So like it means that when I run the 4 models, I can only use this technique on the T1W. So the other 3 just remain as they were using the central slice. So like anyway, yeah, the results it gave me weren't very good, but I think it is because of the fact that I need to clean up the data to start with. The other thing is when I run the...
Oh, I had a question, Steve.
Yep.
When this segmentation says slice, is it because this seems to say slice in 1 dimension, right? So is it slice in the depth dimension only, and X and Y are chopped to the tumor in other ways? Or is it, when it says slice, is it in all 3 dimensions, or is it just in 1? Or
no, it's only in 1. So yeah, so as I say, I can only do it on the T1W images. So you can see here, so like this is a T1W scan that I've put in. And yeah, like for this, whatever, 749 here, yeah, for this patient, their T1W are orientated in the axial orientation. And so, yeah, so like...
Right. But what I'm saying is the X and Y chops, like the red rectangle that it has drawn, does it do that as part of the segmentation? So not only are you getting slice, which I assume is in the depth dimension, but somehow it's also, the segmentation is also helping narrow the X and Y dimensions?
At the minute, no. So yeah, so for like this patient here, their DICOM images are axial, so they've got yeah, I'm not sure how many, but like say 256 different DICOM images in the depth direction.
Right.
So like I give those 256 to the segmentation thing, and for each of the DICOM images, it'll return me the pixels on that image in the X and Y dimensions where the tumor exists. So like for each one of the DICOM images, I can like draw like this box, but at the minute I'm not using that. At the minute, all I'm doing is using it to find which index in the depth dimension has the most tumor pixels on it, just to find the sort of this the central image. But yeah, like so like the next step would be to like to cut it just to that red region there.
Right. So in effect, what you're saying is you're still using all of the XY
exactly
images, but just reducing the slice dimension, excluding all of the slices that don't have any tumor pixels in them, but keeping all of the XYs where, because if you simply can even reduce the because X and Y also has a lot of noise, meaning a lot of pixels where the tumor isn't, but we continue to use them, at least right now. You are continuing to use them, correct?
Yeah, at the minute, yeah, like that would be the next step. But so this here is like the classification function. So like this is his loading function that he uses just to load like the image. And normally it does this thing here where, yeah, like it finds the middle slice just halfway through the set of files. But like in my case, yeah, so if it's T1W and I know what slice index has got the most tumors on it, then I make my middle slice the slice with the most indexes, which is hopefully the slice that's in the middle of the most. But yeah, so like this was just a sort of first step. But yeah, like, so I was hoping it would have given me a sort of slight improvement on just his middle technique, but it didn't. And I think it's because of the fact, as I say, that the segmentation model has only been trained on axial, and you know, like some of the images that come in, they're axial, some are coronal, some are sagittal.
Right.
So yeah, like, so the segmenter can't deal with those other ones yet.
Right, but couldn't you kind of it depends. What is the segmentation model using? Because the walk, you know, if we use the voxels, then that kind of reduces everything to the same orientation and normalize the thickness and all that, right? Like, so what is the input to the segmentation model?
Yeah, so like the segmentation model itself, it was trained on previous Brat's 2020 data. So like, as you say, it was trained on sort of, you know, the cleaned up data that's part of the task 1 competition here. So yeah, it's like sort of the voxel data, or the nifty data or whatever. So like it's all been trained on the axial plane for like cleaned up data, whereas I haven't done anything at all to clean the data at the minute. All I've done is like read the DICOM files and yeah, stuck them straight into the segmentation thing, which for anything that's axial, it works fine. Anything that's not axial, it doesn't work. It's not giving you the right slice index back. And the other thing is, if the data was cleaned up, then like, even though it's only handling the T1W images, if my data was cleaned up, so all of the different MRI types of the same voxel dimensions, and like, then when this comes back and tells me a region, then it'll apply to all of the types. So yeah, like my next step was going to be to clean up the data to try and do that. Then the other thing I found was, yeah, like, I think you've seen this already as well. I'm having trouble. Yeah, like when I actually sort of like then I stick it through the inference thing. So like, this is on the test data. So this has gone through the segmentation model and through the classification model. And this is like the predicted value. I think you've seen this as well. It's like all of my predicted values, even in the notebook that was giving me sort of the reasonable results, the same as what the guy got, they're all like this type of value, which is all sitting either side of like 0.5. So like, they're not sort of really sort of making strong predictions either way as to if MGMT exists or not.
By the way, the thing that I hope we discussed this, I thought we did in the last 2, is this, you know, the efficient net PD, whatever, the 3D PyTorch model, that has problems.
Yep.
So in fact, all of last week I spent just getting an alternate 3D ResNet model working, which I did get working, so I can share that. You know, the notebook I'll post in Slack, or I can even show you. But that, and I applied it to the voxels and I got it working. But the 3D efficient net 3D blah 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 notebook that many people have used, it has issues. It doesn't work.
Okay. Yeah, so like, I haven't really thought about that bit much yet, because yeah, like I'm still sort of trying to narrow down the segmentation thing to identify the tumor.
Yeah, no, because I just spent time, because I was frustrated. I mean, Mehul saw this. You know, he was getting all 0.5, and then when I ran it, it was giving all of the outputs to be identical, blah blah blah. So, and then you know, when Mehul, I think pointed to somebody saying, oh, you just run it with train, but that's actually bogus because you can't just run evaluation under train because then, your dropout and other things don't work appropriately. And then I think I pointed to the whole that somebody in that thread itself said, oh, I'm not maintaining this code that everybody is referring to and using. So if it doesn't work, sorry. And so I was like, okay, that's not a good sign for using that model. So I spent some time last week getting a 3D ResNet that is built on the fly. Now, of course, it isn't pre-trained, but at least it works and gives, I think, appropriate results because at least the results for each are different and they're not all the same number.
Right. Yeah, so I hadn't really got that far. So as I say, I was at the stage now where I needed to clean up my input data a bit more. So like the notebooks that we've looked at before do it a bit, but this notebook here, it was just released yesterday. It's like the weights and biases guy that talked to us a while back. So he's basically he's taken these other 3 notebooks which we've looked at before and sort of combine them into a library, and like with that then it will run this sort of cleaning up and referencing and stuff. So he's got a bit in there like which looks at the sort of the metadata in the DICOM, and then with this notebook you can process all of the images, so you can so like it where did that go? So you can see here like it processes the 4 images and makes them all, he uses a single reference image. But what I found with his code, the problem is his reference image, you can see like when the large selection comes up, everything has been cleaned up and like everything's all the same size, but you can see here the top of the image goes missing. Because the reference image he's chosen obviously has a different sort of central orientation, central point than the others. And so like, although everything's ended up at the same size and cleaned up, it's not quite right because of the fact it's chopped the top off. So I was just like trying to deal with that. Like instead of using one central image, I was going to like just use say like the T1 image to clean up its own other set of MRIs. I'm still working on that at the minute, but this notebook here, if you do that, some of these images are like sort of 512 by 512. They're pretty big. And actually, like if you run this notebook on the full data set within Kaggle, it ends up running out of disk space. So I haven't been able to generate the whole training set yet in a cleaned up way. But like all of this has got good stuff in it, and I should be able to work around it. And it is compared to like Mehul was showing last week, his other library, can't remember the name of it, but it was very slow, the one he was using. This one here can sort of
CPK or something.
So this one can like sort of clean up the images and set the references and stuff in for the whole sort of training set in about an hour or so. So like it does like still leave enough time to actually work with the data after that if you like were to apply it onto the test set.
Yeah, so I'll look at this. That's a great point. If it just came up. The one comment I have too is I'm still not convinced that that whatever the I forget what term Mehul uses for registration or whatever of to an atlas, as he calls it, right? Like which is kind of getting all these 4 types synced up with one image of a particular orientation is necessary for anything, but because as we discussed, it's definitely not necessary for classification. The question is it critical to do for segmentation, and it would be if, I guess, you use one model for all 4 types. But if you segmented each type individually, then the segmentation model should give you the pixels, like you said, of the pixels on the tumor for each type. And if you independently ran each type, then I don't think, again, why locking it to reference atlas is important. Any thoughts on that?
If you can see these images here on my screen now, so these images have been generated using the weights and biases guys code, but rather than using one reference for all of the study types, it uses the study type itself image. So like for study ID 0 here, I've used the T1W. This is the reference. And so like when it makes the flare, unlike these other 2, it ends up, so you can see they're all pretty much identical shape and like position. And the other thing it does, so it cleans them all up. All of them have got exactly the same shape when it finishes, which is really good for me, because of the fact then I can take this one here, which is the T1W, I can put it through the segmentation model, which will give me the pixels exactly where the tumor is, and then it'll apply to the other 3 as well. And so like then, I can sort of zoom in on the tumor for any of the MRI types. The only problem I have is...
question. Sorry to interrupt, but there's one question while you're at it, because what is the way by which you make the thicknesses of these the same?
I have no idea. I stick it into the library that gives me back the thing. So
okay.
It is basically from the notebooks we've looked at before, like the voxel one and stuff. It is just
okay. As long as,
all of their code too.
If it's using the voxel code, then because the thing that the voxel guy does, which is I think the right way to go about it, is he uses the most dense pixel dimension in order to interpolate or extrapolate the pixels in the other dimension, which I think is the right way to go, because you are using the dimension in which you have the most pixels as the correct way to interpolate. And I think I just was wondering if this is different. If it uses the same code, then that's a good thing.
Like I think all the codes like from the sort of stuff we've seen before, and so like it does the resampling here, so it takes the reference image and then it's using that SITK library, and so you can see it's like sort of setting the size to the same size as the reference image, and like setting its orientation and stuff to whatever the reference image had. But the one problem with doing it the way I have, so you can see here the first image. So like this T1W, I think has dimensions 33, 512, 512. And then by like using that code and using this as a reference, then these other 3 within the same study, they get changed to have this exactly the same shape. But then you can see on the next one here, this T1W image has this size. And so like, although like the images in the study get set to be the same size as the T1W, it means that every image across the studies has different sizes. And I think that's part of the problem as well, because of the fact that like this is generating me 512 by 512 images. It ends up like with a massive size, and I run out of disk space on the Kaggle kernel. So like ideally, I would want everything to be like down at 256 by 256. So I need to find a way where I can sort of tell this to use a smaller size. Plus as well, I think here, I'm not sure if that's axial. And so like, because of the fact that this T1W image, I've used it as a reference. If this isn't axial, then these end up not axial either. So again, I need to find a way to sort of give it an axial one and reduce the size. But yeah, I've only really started looking at that. So, but that's as far as I've got so far.
And this particular notebook that you're using, which is it using the latest that voxel thing that you pointed to? Is it using that notebook to do the for lack of a better word, voxelizing, or is it using some other earlier notebook as a reference?
No, it's using like that one that I showed you, like from the weights and biases guy, which it only came out yesterday. But effective, what they've done, they've taken the code from sort of the other notebooks we've looked at, like the ones that set up the voxels and the ones that do registration and stuff, and combined all of that code into like a GitHub library. So like they've sort of centralized it all into a single place, and they've added in the code into this GitHub library as well to allow you to get the metadata from the DICOMs. Yeah, so like they've sort of taken the best bits and pieces from sort of the popular notebooks for this competition and made a library from it, which you can pull in. But yeah, like it's not any different. So they haven't sort of actually made any new sort of changes to the code. It is everything we've looked at before, but it's just sort of combining the bits and pieces together.
Yeah, that's pretty good progress that you made. I mean, it's not like I said submission yet, but I think it's all the work to get to the right answer, right? I haven't in fact touched anything on segmentation at all, so maybe I can combine I've just been focused on getting I haven't even submitted once. I just wanted to get a 3D classification model working. I was frustrated by it not working. So
yeah, that's the thing. At the minute, I've spent all of my time has been spent like learning about brain images or whatever, and how to mess about them. I haven't actually done any machine learning stuff at all, really. And like, as you
yeah,
say,
no,
like
that
the efficient 3D model that I've been using, it may be like a load of rubbish, but I haven't got as far as sort of testing that out yet because I've been too busy shifting pixels around the place.
yeah, no, I think as discussing with Mehul too, right? So let me share why. Let me know if you can see my screen.
Yep.
Yeah. So so here I'm just using the voxels thing that we looked at, I don't know, several meetings back. It kind of converts to 3 different sizes: 64, 128, 256. And then I'll show you a little bit later why I switched from the efficient net 3D. But I kind of, also struggle, although there are different methods. I think I asked Mehul too, and he said he will post a link to Slack a little bit later of the Monai 3D model, but that works off of Nifty, whereas obviously I wanted things to work off of NumPy. So I poked around and stuff, and eventually I found a guy's code that I don't know why he does it this way, but I didn't want to make too many changes to it. I just wanted to get it working. So he builds 3D ResNet, essentially a ResNet, and then a 3D version of it. So this is all the code for doing that, right? A bottleneck layer and a 3D basic block or a downsample block. And then, the expansion depending on when you want larger sizes. And then he builds the ResNet 3D and then kind of has these different sizes that it can return. And then, you just provide it either the basic block and the number of layers you want to build different levels of ResNet, different sizes of ResNet. And then you generate the model using this. I don't know why sends it in and then anyways doesn't use the value. But anyway, those are details. I got the stuff working, whereas earlier I used to do the efficient net 3D, the B0 override, blah, blah, blah. But found, as I'll show in a minute, after we are done with this notebook, why this was a problem. And then I got this thing working. So I submitted, and in this case, you can see that. Oops. Let me see whether T2W. And the good thing is here you can see the NGMT values being quite a bit different. Right, some are 0.3, some are 0.2, 0.6, 0.4, 0.38. So you see variations, right?
Yep.
Whereas, and this is for the flare type. I was individually trying each type to see that they work. If I, on the other hand, let me show you with the efficient net 3D stuff, what happens when you run it. You can see the structure of it is the same. You see how all of these are the same.
Yours are identical though.
No, exactly, and that's weird. And at least this is the efficient net 3D model.
Yeah.
So that's the problem with that model. I don't think that model is correct, and we shouldn't be using it. And it's not just this. In fact, as I said, I do it for multiple types, and look at, while it may not be exact, look at how close each of them is still. So that particular efficient 3D PyTorch thing has a problem. It's actually off of a GitHub. I don't know whether that GitHub thing is being maintained or whether the notebook has been trained properly and all of that kind of stuff. So I don't trust it.
Yeah.
Whereas, as I showed you, let's see which one is that. Yeah. If I do it with the ResNet 3D stuff that I built in this notebook, then I get this type of result. Right. Of course, I haven't yet submitted. I'll submit to see, whether the to make sure that I don't have the problem that Mehul was referring to, that everything turns out to be 0.5. But I don't believe so, because I do see the AUC varying, and I get different AUC. Yeah, here you say validation. In this case, I'm not ensembling, but I see around 0.59, which is still a low score. But right now, I'm not so worried about that as I am about, hey, is the model even getting to be appropriate? Because I'm using a lot of noisy data, right? I'm using the entire 64 by 64 by 64 pixel voxels. But you can see that the AUC score is changing, and I think the model that it ends up with is this 0.938, and that's the case for. Okay, now this is the flare, but if I look at T2W, for example. I think T1WCE, I think, is the one that gives the best results within just the 4 data types if you end up using all of the data. Let's see, remember we got 0.59 in the other case. Yeah, you can see some 0.6s and 0.67. 0.645. So you can see that it's also varying from type to type. Right. And you get AUC of 0.61 or 0.645. So I trust this model that at least it's working, whereas the EfficientNet 3D thing has problems. I wouldn't rely on it.
Yep.
Just FYI. So that's what I spent my time trying to get this thing working, because I wanted at least one reference 3D model to work. So that's kind of what I did last week. Now I have to submit and make sure that I do see a difference, and then begin to kind of move into the into your segmentation domain to see which of those segmentation approaches to use.
Hi Srinivas. I have one doubt. Like when you're loading the image, why are you like giving like np.load of like 3? You have read a voxel and give it as 3. It's an already a voxel. Then in the data set, it's already in 3D image, right?
Yes, but it's yeah, that's something I changed as well, because the input to the EfficientNet 3D was it's 1 by 128 by 128 by 128. Whereas here I'm providing it as a 3-channel input.
Okay, for
It's
each channel,
3D.
okay, it's okay 3D. Okay, for each channel you are
3D, but
giving
3 channels.
Okay, okay.
Whereas, like it's like saying you have, let's say a 2-dimensional image, which you typically give for a 2D, but that can be 1 by 128 by 128, or it can be a 3-channel by 128 by 128. And these ResNet models are built to handle, I mean, you could change it to be also 1, but the ResNet default is 3. So I just duplicate the 3. That's a good observation. I changed the voxel building to, where is that? Let me show you where I did that, because that's not what the guy does, but I changed it to be compatible with the ResNet model that I'm using. That's a good observation that you saw that. Let me show you where I, here, this is all model related, but where I'm building the data, I made a change. Yeah, here. So here, after I
Actually,
built
one
the voxel.
sorry, Srinivas, you are not like you're not screen sharing.
Oh, sorry. Okay. I hear that. Can you see my screen now?
Yes. Thanks.
Okay. So here, this is where he builds the voxel, right? The thing, that notebook that Steve was referring to earlier. And what I do is, after I built. So you see my comment here. So I stacked the voxels to make a 3D, make it a 3-channel 3D image.
Okay.
Right. And the second reason I did this, the first reason I did this is obviously what I told you, right? That the ResNet models are built to handle a 3D or a 3-channel input. I shouldn't say 3D, a 3-channel input. So this is now a 3-channel 3D image instead of a single channel 3D image. So you can have a 1 by 128 by 128 by 128, or a 1 by 256 by 256 by 256, or you can have a 3 by 128 by 128 by 128, or a 3 by 256 by 256 by 256. And this is a 3 by a 3-dimensional image. So 3 channels of a 3-dimensional image. So each image is 3-dimension. It has X, Y, and depth, but it has 3 channels, right? And the reason, so that's the primary reason I did it. The secondary reason, which I think, Mehul and Steve had mentioned, and I think we discussed offline, but it's somewhat relevant, is I wanted to build the capability to potentially provide in each of the channels. Now I can provide an MRI type, provided of course that the MRI types are aligned, that is, they are made of the same axial sagittal coronal thing, as well as in that case they need to be registered to the same, as Mehul refers it, atlas, because you want the channels to be, for lack of a better word, properly aligned. There might be a medical term for it that Mehul would know better, but you want, imagine a bear in RGB 3 channels, right? So you don't want the red bear and the blue bear to be off kilter. You want the bears, the red bear, the green bear, and the blue bear to be all aligned with each other. So that's another reason I did this, is because now this same ResNet model, I should be able to provide an MRI type different in each of the channels. Of course, I need them to be properly aligned, but if I did that, then I have built in the capability to be able to handle multiple MRI types in the same image and do the segmentation and classification.
The code you've used here to create these voxels, is that from the notebook that takes the DICOMs and converts them to PNGs?
No, Steve, this is actually, I use them only for inference. I actually, it's the same, it's a different notebook that Mehul had originally pointed to, which converts all of the voxels from, or creates the voxels all of the same dimension, meaning 64 by 64 by 64 or 128 or 256. And there's a reference notebook that does this. And for my training, I actually input a data set that's already created by the guy. And the reason I have the code in there, his code, is because, of course, you need to do the same thing for inference.
Yep.
So that's a guy who generated, and I should change this. I'm no longer using this efficient 3D model. Forgot to change that comment, but and I, at least right now I'm not ensembling, although I would like to ensemble the 4 models. So you see this, these are the 3 kind of.
Yes, those voxel data
I don't
sets,
import all at once.
It does the thing about like sort of, yeah, they're all sort of put into the same plane, and sort of like left and rights are all made consistent, aren't they? But it just hasn't done the registration bit. Okay.
Except for the registration bit that Mehul ref was referring to.
Yep.
Registering to that atlas, it doesn't do that.
Okay.
But you see this, it kind of makes that the same. Then, what else? Yeah, so he, by the way, the other thing, Steve, that could be a problem also in your segmentation and stuff is not only is the orientation different, meaning it could be coronal, sagittal, or axial, but the other thing which this guy has found, and therefore he fixes it, is the ordering is different too. By the ordering, he means that, you know, let's say it is sagittal, right, which is, if I recollect correctly, it's from the left ear or the right ear. It could be right. It's the image of the brain going sideways, and from the left or the right. And if that's the case, the other thing he found is some are from the left and some are from the right, and that requires a reordering of the images. So that's what this reordering stuff is. So not only is it some are sagittal, some are axial, some are coronal, but even within sagittal, some are taken from the left and some are taken from the right. And if that's the case, it needs to be flipped to be the same.
Yep.
And the flipping, by flipping, I mean the reordering. So it's everything is from left to right or everything is from right to left.
Okay.
Right. And then, of course, he normalizes and crops. And this is where I was telling you that he does the resizing based on whichever dimension has the most pixels. And he has the comment to that effect in the original notebook, I believe. And then, of course, I made the change to make it a 3-channel 3D stuff. And then, of course, you can use, this is the place where you would do what, you know, in your segmentation you were doing, right? Which is to say within the voxels, once, if these voxels could be used as input to your segmentation, then once you get the index, then you would use that index to kind of reduce the voxels where the tumor voxels are.
Yep.
Right, and this is where I think, was it Siva who pointed out, right? Like, so this is where I'm changing it from what used to be a 1 to a 3.
And one more thing, Srinivas, like in that, like in the voxel where we are giving slices, right? Like Steve pointed out, like we can able to find the slices when in some steady IDs, the slices, the tumors present the slices will be different, right? So at that point, what we can do, right? Anyway, if when you are feeding the model, we just need to give the same size for every steady IDs, right?
You're saying, does this have to be all the same dimensions?
No, yeah,
They don't have,
similarly, like if you are giving
yeah,
some
they don't
slices,
have to. Go ahead.
okay, yeah, like it's okay. My question was like these slices should be the same, right? Like if you are giving like in that slicing part to for example, if a steady ID 0 as like and the tumor has present the sizes between like 15 and 30. Only there the tumor is very is an high percentage where you will give the on that window size only, right? So if
Yes.
we are loading, if you're loading that and next ID where the slices the number will be different, then
Correct.
we can all still use that same, we can't use the same for the same same, what do you say? The same part or the range which were used in the steady one, right? So can we give different slices values? That's my question.
Yes, yes, you can, because ultimately in a RESTnet, in a properly built RESTnet or a fully convolutional RESTnet, the final thing doesn't depend on your input sizes, right? Even in 2D. Even in 2D, you can use any size image. One image size can be 128 by 128 and another can be 224 by 224, and you will still get the proper classification. And that's because of the property of fully convolutional networks, where eventually you average pool, or you max pool, or you combine the two. Therefore, you're not dependent on your input size. That is, your classification works regardless of change in your input size from image to image. So because of that, it's not a requirement that, right now, for simplicity, because all the voxels, we are using the complete voxels, I just set it that way. But if these slices turn out to be different sizes, that's not a problem. This dimensions will change, but that's like changing in a 2D space, the X and Y dimension, which means that each of your image going into the ResNet convolutional network is different, and that's fine. The network can handle that.
Okay, thanks.
Okay. Anything else? Anybody?
Yeah, only one thing. Like I also worked on the same. I was trying to use the efficient 3D model, and with the 6464 the voxel dataset. I just trained on one type. The LR finder also, the learning it also is not too good to bad. But I'll just try it out with 4 different models just to generate a small baseline without using any data augmentation, anything. What score will be? I just need to check it. After that, like you suggested, like we can move to this kind of models where we just generate from scratch, like something.
Yeah, the efficient 3D model is broken in some way. I don't know how or why, but it's not. I don't think it's functional. It has problems. So I would say, use a different model than that, because it's generating bogus data as output, I feel.
At the minute as well, I think it's hard to sort of judge performance on the leaderboard for a couple of reasons. Like, as people have pointed out in some of the notebooks and some of the discussions on the competition, I think even if you just like put in a sort of random set of like 0.5s as your sort of predictions, you end up like with a score on the leaderboard of about 0.64. So I think if you're getting 0.64, it's sort of like a random score, and you need to get higher than that. But then again, on the leaderboard at the minute, there's scores in there that are like 1.0 because people have been probing the leaderboard, and there's a lot of discussion into that as well, where people have come along, and it is possible to probe the leaderboard, and people have done it now so they know exactly what the MGMT value is for every single training sample in the public training set. So it is hard to sort of get a score on the public leaderboard that you're happy with, and that's not just a random score.
Yeah, no, that's a real problem, Steve.
Yeah, I don't know what they're going to do about it as well, because like in the final sort of private test set, when they do like the final evaluation, they'd initially said that like 20% of it would be from your public score, and then the other 80% would be the other hidden test samples. But they can't really include people's scores for the public 20% if people know exactly what value they have. Yeah, because supposedly there's
Yeah,
like a lot of people
that
cheating.
seems like a total cheating, right? I mean, that should just be excluded.
Yeah, there's people who are creating like dummy Kaggle accounts so as they can probe the leaderboard to find these answers, but like it doesn't affect their sort of their final submission. So yeah, I presume they'll have to do something about this.
Yeah, I agree. They should be doing something because that just makes it, it's like, oh, on 20% I get a perfect score, and on the 80% is where I'm actually getting tested.
Yeah.
And that makes little sense. But that's one reason, by the way, here's another thing I would like your thoughts on. That's one reason I thought that, some people, and obviously the current notebook I have only splits, it does a stratified split, but it does just a single split and runs the model and tests it. And I saw a few others using a five-fold split, and I thought that that's a better idea because you get some variations, and obviously five-fold CV is better than just a single split CV, right?
Yeah.
So I was thinking of again making some switches here, or making some changes to this notebook to adopt five-fold CV, and then using the final model on the entire training set instead of the folds. That is, get the best model from the five-fold and then retrain it on the entire training set, and then use that to do the prediction.
Yeah, sure. It's just, again, I don't really have a model that I feel is actually sort of training or learning anything. Like all of my models, like they're still sort of like having really high loss. And so yeah, like until I've got
You're
one that
right. I
I've sort
mean,
of,
this is all assuming the model is right, and which is the work you're doing, which is to get the model to focus on the data that really matters. Because all this model, I think, well, the model itself maybe, meaning the classification 3D model ResNet may be fine, but it's kind of working on a lot of bogus data.
yeah. So like once I've sort of got down the road a bit and actually got something that looks like it's training, then I would do the K-fold stuff and try and improve things from there.
Yeah. No, I think the getting, as Mehul also has repeated, right? That's why he had sent a couple of notes to the organizers of the competition saying, hey, if you did all this segmentation, like this CPTK process or whatever for the PRATS thing, why don't you release that data? Because that makes the problem, I guess, I mean, that at least minimizes or reduces the focus on the data prep, because like you were saying, most of the focus otherwise is on just the data prep part of it, right?
Yeah. I presume they'll not do that now, though. It's too late into the competition, and like people have spent so long like working out how to like manipulate the data. They wouldn't be happy if they suddenly turn around and release nice, clean data. Yeah, like my
When
last.
does it end? I haven't looked at when does this thing end? September? I mean, end of September or October? Or
I think when I was looking the other day, like previously it had been on sort of 2 months to go, and it had dropped to 1 month to go, but I can't remember when the exact deadline is, but about a month away, or maybe slightly longer, but not that far away now.
Oh, October 15th, final submission deadline.
Yeah.
About a month and a half, or a month and a week. And you have to merge the teams by October 8th. Okay. Don't have that much time then. Time flies.
Yeah.
Yeah, barely gotten a 3D classification model to work. Okay, everybody. Thanks for joining. Anybody else? Any questions, comments? If not, good luck with more work on the competition this week, and we'll do it same time next week. Thanks, Steve. Thanks, Deva.
Cheers, guys. Yeah. See you next week.
See you.
Thank you.
Yeah, bye.
Thanks all. Bye.
Bye.